Right, what is up, YouTube? Mr. Porkchop back here after quite some time off from YouTube. This video basically today is going to teach you guys how to create this little game basically that I'm showing you here. It's pretty much just like a little player that can kind of move around a map. It's nothing too crazy, just one tiny little player and a map, but um, yeah, it'll be kind of fun. I am just forewarning you guys, this video is pretty lengthy and it's a lot of me kind of reading from a book because I don't have the book with me right now, but pretty much I just followed directly from the book how to create this. I'm trying to learn C# and Unity, and the best way for me to do that was to just buy a book off Amazon and start doing some projects. So this was the first project that I really attempted. Um, it's probably going to be a little difficult to follow, but feel free to drop me comments or join my Discord if you guys want me to kind of explain anything else further about this project. For the most part, you should be able to follow along. It's been a little while since I made a video, so I'm a little out of practice, and there was like sections of it where I'm not zoomed in fully, and other sections where like I forgot to zoom back out. So I had to basically um, just add in sections going over the code that I typed, so you won't actually get to see me type it. Um, so, there are some issues with it, but for the most part, you should be able to follow it and build this program. And again, like I said, just drop me some comments if you guys have issues with it. Let me know what you think about it. Yeah, and I guess one other highlight to mention is like my channel now just opened up the community tab, so I can make little posts and do like polls and stuff, so that's pretty cool. I appreciate you guys, everybody that's subscribed to my channel and that likes my videos. I really appreciate it. If you're not subscribed, I would appreciate you guys subbing to the channel. I will continue to create content. It's just going to be a little farther spaced out now, just because of work and life and and everything else. But I am very active as far as answering comments and in the Discord if you guys ever want to talk or need help with anything. Alright, good morning everybody, Mr. Porkchop back here with another video. Today's video, I am going to start my, kind of like the next project that I've been doing in Unity. So I've been going through this book here, game programming with Unity and C#. So I'm going to show a section of it, which is chapter 13, an obstacle course design and outline. Yeah, so I'm going to kind of basically go through and build this little project, and I'll show you guys how I do it. So yeah, let's get started. First thing to do is to open up Unity and create a new project. So obviously if you don't have Unity downloaded, I would download Unity and then also download Visual Studio Code. That's pretty much what we're going to be building or using to code all of our scripts. So you click on new project, 3D core is fine, then you can give your project a name. I'm just going to name mine obstacle course because that is what we are building. Alright, so I'll create our new project here. Alright, so we have our project right here. This is our project folder. You can see we have a folder named scene. We're going to add a few more folders here. Create folder, and inside our assets we're going to have materials, and we're also going to have another folder called prefabs. So in assets we have materials, prefabs, and scenes. scene already has our one main scene. And actually we're also going to add one more folder here. It's going to be called scripts. So now we have everything for our stuff. Alright, then we're going to go into this folder here, and we're going to rename this guy to main. That would be our main theme. Alright, so now we're going to add a floor. So we're going to go up to our game objects, and we're going to create a plane. Alright, we have our plane, and then we're going to navigate over to our inspector menu over here to kind of set it up. So the transform position 0, 0, 0 already. So this makes the position, make sure that it's centered in our scene. To make it large enough that we shouldn't have to worry about running out of space, we'll scale it to 1001 and 1000. So scale will be 1000. We'll keep Y1 because we don't need it to go, we don't need it to be thick, we just want a thin floor. 1000. So that'll give us plenty of space. As you can see, I can zoom out and like, this is a pretty big, pretty large floor. You know, we're not gonna run out of space there. Okay. Now, the project view should look something like this. That's fine. Okay, player movement. With our new project in place, let's start coding our player's movement. We're going to get a little fancy with it to exercise our programming skills and learn about new methods. Alright, so we're going to create an empty game object and name it player. They have a shortcut key, I guess, here on Windows, which is Control-Shift-N or Command-Shift-N if you're on Mac. So we'll do Control-Shift-N. Let's create a new game object, and we'll call this game object player. Now we're going to create a cube that's a child of the model by right-clicking the model in the hierarchy section. So over here we can see we have our game object player, and we can create, how are we doing this? Create a cube that's a child of the model by right-clicking the model in the hierarchy and selecting 3D object cube. Name this cube base. Cube. We'll call this base. Alright, so now you can see that we have our player object with a child underneath it, base, and basically a child object is just anything that's attached to another object. So you can see like our player object would be the parent and base is underneath it, it's attached to it, which would be its child, which means it inherits pretty much all the stuff that we give to the parent. Alright, so we set the position to 0.25, so position 2.5. I probably zoom in a little bit so we can actually see what we're doing here. We have two little cubes. Alright, set its scale to 1.4. And this one is going to be 5. This one is going to be 1.4. Oops. 1.4. Alright, so that's that. Alright, so now we're going to create a second cube on top of this one, the object cube. So now we have another cube underneath our base cube. And we're going to name this one top. So we'll just name that top. And then the top cube So the position for the second cube is actually going to be 0.5 for our top cube, and then the scale is going to be 0.33. Whoops, and we're supposed to move this to 0.5 as well. And then this is going to be 0.1, and this is going to be 0.7. All right. There we go. So now we have like our little player, basically. It's like a little cube with a little head. That's basically what we're going for. Now that we have all of that, our player's kind of pretty much ready. So the main camera object should already be present in the scene. So we're going to drag it to the player game object. So main camera is here, and I guess we're going to drag it to the player. Making it a direct child of the player root, not the model. So I think I need to move this up a few. We want it to be a direct child of the player, not the model. Drag it onto the player game object, making it a direct child of the player root, not the model. Player root, not the model. For now, we'll give it a local position of 0 to 5 and rotate to put it to a point over the... So wait, I think they said the player root, I think, is going to be top then, right? Not 100% sure, but I said to drag it to player, so I'm just going to leave it where it was when it went to player. We'll see if I did it right after that. It looks right, according to the picture that they have here. So after that, we'll give it a local position. So the camera is going to have a local position. Transform's actually folded down right now. We're going to give it a local position of 0, 24, and -5, and a rotation of 70. So rotation X 70, and then we're not going to give any more. Those two will be 0. So now we can create a prefab for the player by dragging the player from the hierarchy window to the prefab folder in the project window. So player, go right into prefab. So now we have a prefab of player in our prefab folder. So we can hang on to that. The top cube will poke out along the forward axis of the player, the facing direction. This way we always know where the player is pointing. So that's why we did that little like square at the top. Basically, you can just tell where it's pointing. All right, materials and colors. So we want to color the cube, each one a different color to the top stand, blah, blah, blah. So we can use material. A material is a built-in Unity asset that stores information about how a mesh or 2D image should be rendered. Most notably, they're allowed to apply textures to meshes. Textures are pretty much normal 2D images that are stretched over and wrapped around a mesh, a 3D object. Alright, so that's what we're going to be trying to do. So we're going to create a material named player base and another one named player top, both with your materials folder. Both within your materials folder. Alright, so in my materials folder here, we're going to create a material. Let's call this one so call one player base, and then we're going to call another one player top, I think is what they say, just to correspond to our two different player pieces. Alright, so with either one of the new materials selected, the inspector will show a somewhat daunting list of fields we can edit for the material. Luckily, we only need one little control. Near the top, beneath the bold text main maps, there's a swatch of color to the right side of the word albedo with an eyedrop icon beside it. This is a color fill material. By default, it's a shade of white. Click that rectangle to pop out a color window that lets us change the color. Alright, so right here I would assume. So we can make that one red. And then this one can make blue. Alright, and then I would assume we just attach this to our object. Yeah, like that. Boom, we have a red and blue object. It's like a little player. Very cool. Alright, let's learn how computers look at colors. That's, I don't really want to read through all that. So we'll go to our script folder, click create, C# script, call this player. So now we have our script, and then we can take our script and just drag it to player and attach it to player. So now you can see if you click on player, it has the player script attached to it. If you want to open the script, just double click on the script, open. The first thing we'll do is declare some variables that we'll be using to handle the movement of the player. They'll go right in the top of the class declaration for our script. Okay, so public class player, mono behavior, that's where we are. We're going to go right below that, and we're going to just do references. References. Something out. So header movement. Wait. Header movement tooltip. Okay. Public. Float. Move speed. I totally F this up. Alright, that's better. So units moved per second at maximum speed, and then the bottom one over here is going to be the other one. Okay. That's good. Now we're going to do... Alright, hold on. Tooltip. Time in seconds to go from maximum speed to station. recording. Alright, so moving on. The next day, I'm going to start working on this project again. I did add a little bit of code before I started recording, which was just these two methods here, the movement update method. Haven't put anything in them. About to do that now. Actually, let me do this here so you guys might be able to see a little bit better. I think that's a little bit like that, maybe. That's almost a little too zoomed in. Okay, that's probably a little better. Yeah, we'll do that. Alright, that way you guys can actually see what the hell I'm doing. I'm pretty sure all this is going right into our actual private movement method. So we'll start here. If input get key. So essentially what this is showing, which I know it's kind of off the screen right now, apologize for that. So that's really what it's showing there. Or maybe I can just shrink this down a little bit more.
I guess that's I'll just do it like that so you guys can actually see what I'm doing. Alright, so essentially what this is doing is basically taking our movement speed and then this math.min function basically takes two parameters and gives you the um, lowest value. So like basically we have our minimum value, which would be like move speed, and then we have the current value plus what we're going to add to it. So if this right here ends up being higher than or ends up being lower than like our minimum move speed, then we'll just get the minimum move speed, and then if it's not, then we'll get the actual result of this addition here. Okay, so let's kind of break this down, keeping in mind that velocity dot z will be negative if the player is moving backward and positive if the player is moving forward. Velocity z is move speed. So then the player is moving at full speed if velocity dot z is move speed, is minus move speed, negative move speed. Then the player is moving at full speed backward. Alright, yeah, so basically if velocity z is move speed, then the player is moving at maximum speed forward. If it's negative move speed, then it's moving maximum speed backwards. If either the W key or the up arrow key is held, the player currently has forward positive momentum or no momentum at all. Then add to the forward movement, but never let it go higher than move speed. And the player currently has backward negative momentum increased, and then the reverse momentum multiplier, since the velocity is negative, we don't allow it to go over zero. This way, as soon as we hit zero velocity, we stop using the reverse momentum multiplier. Alright. Understanding this should be fine for the rest of this chapter. Whenever we change velocity, we change it using the concept of min and max to clearly cap the value while we assign it. The amount we're adding to the velocity to increase it is making use of one of the properties we declared earlier, velocity gain per second. let's take a look at that, at the amount we're adding in seclusion when not reversing momentum. So it's movement velocity dot z plus movement gain per second times time delta. This is fairly straightforward thanks to the property. It practically describes itself in plain English. We start with z velocity and add the velocity gains per second. Since it's per second, it has to be multiplied by time delta. As we learned before, another thing we previously learned, that the multiplication operator will take precedence over the plus operator or the minus operator. This means it's always calculated first with whatever is on its left and right side, and then plus or minus will be calculated with the result of that. So we know that velocity gain per second alone is being multiplied by time dot delta time, not the result of movement velocity time dot z plus velocity gain per second. If you want this to be visibly clear, you can use parentheses, blah, blah, don't need to worry about that. Alright, we're reversing momentum. We have basically the reverse momentum multiplier. Alright, so now we are doing some more. We're going to add in another if-else statement. Forward. Gain per second. By our Alright, so that should be what we need for the backward movement. So we have forward and backward movement. All set. Alright, then can I go through all this other? Alright, so now we're going to do one other thing here that is going to kind of say what to do if we don't have the forward or backward principles, and apply them to the right and left side of forward and backward. To write this code, we can recycle most of what we've already written. We'll copy and paste the code that handles forward and backward movement, everything in movement method so far, and then change the hotkeys to A and D and left and right arrows. We'll also change any reference to the Z-axis, instead reference the X-axis, and edit the comments to keep them accurate. Be diligent with this. If you accidentally leave a .z instead of an X, somewhere you'll be in for some unexpected behavior. Okay, so essentially we copy everything inside of our movement here. Copy, and then let's come down here, paste it all, and then we will do A and D. So let's do A. Left arrow. This is going to be X. So, oh, whoops, that's actually, I did that backwards. The first one is supposed to be D, so this will be right. So D, D, right arrow, already moving, right. Alright. Make sure this is X. So we increase the X velocity if we want to go right. Just gonna make sure I do all of these. Movement. So 1, 2, 3, 4 blocks. Nice. 1, 2, 3. Okay, no, it's just 3. Alright, yeah, we're right, we're right. I did put a space. Just want to make sure I'm not changing something I'm not supposed to be changing. Okay, so that's the first one, which is D. The second one is going to be A. So I think we're good. I think we did everything that we needed to do. All these are now X's. That's now A. And this one is now D. Alright, I think we're good. So now applying the movement. This leaves us with nothing left but applying the movement velocity to the player So the player will actually move. To do this, we'll use the character control. This is a built-in Unity component designed to provide movement and collision detection for a character. If we just move the player by setting their transform position, it wouldn't detect collisions. The player would pass through everything, but moving them through a character control component will cause them to bump into and slide against solid objects in their path. Okay. So first we're going to set up the character control component on the player game object, the same one with the player script component attached. Add a character controller by selecting the player in the hierarchy. Okay, so let's go back to Unity for a second here. I guess let me remove this zoom screen so you guys can kind of see what I'm doing. Apologize for that. Yeah, essentially I clicked on the player, and then over here in the inspector you can see add component. You click on add component, search for character controller, or just go to physics, and then inside of physics you can see character controller here. That's how I added this, and then we basically just added in the center of 2.5, radius of 1, and height of 5, and then you can see it filled in for our character. Alright, with that set up, we can now set the reference to the character controller variable that we declared in our player script. Applying references to components in the editor like this can be done in various ways. In the inspector, click the little circle icon on the right side of the character controller field in the player script. This opens a pop-up window that lets you select any game objects in the scene that have a character controller attached. Click 1 to set the value. Okay, so alright guys, so this is kind of funny. As you guys can probably see now, or maybe I'll zoom in for you guys so you guys can actually see a little better. But if I move this over here, my goodness, this is really hard to do right now. Okay, yeah, so as you can see here, I now have inside my script the trans model and character all right here. This is basically what was missing. I just needed to save my script. So basically when I saved my script, then it updated inside of Unity and all this stuff became available. So yeah, that was just dumb on my part. I guess I didn't realize I had to save it. But now I can basically take my character controller and drag it into this spot here for character controller. That should make a reference to my character controller in my script. And then the trans is, I think, just as transform, which goes there. Now the one that I'm not sure of is, it says model trans. Okay guys, so I totally effed up and totally forgot to add like a layer of the player. So my prefab player was supposed to have this object here, model, and then the base and the top. So I just forgot to do that. So I had to go into prefabs, I had to open up my prefab, and then once there I just right clicked and clicked on create empty, and then put the model in place. And that way model is what's supposed to actually go to model trans, which makes sense. So yeah, let's try this one last time. Alright, cool. So guys, I got it to work. It was actually working the whole time. I think I just didn't have anything next to me for reference, so it didn't look like I was moving. But like, I was definitely moving. So, if you see now, like, now we have this little box that I put here. So like, you can kind of see that I am moving around the box. I just needed something as like a reference to kind of show that I was moving. So yeah, it is working. That's awesome.